In continuation with the Newton's laws of motion, now we are discussing about the banking of roads. So first of all, we will discuss about a car taking a turn on the level road. Basically, in this concept, we have to use the concept of centripetal forces, the centrifugal forces, then weight of the car acting vertically down, and the track on which the car is making a turn. So from there we will draw a normal to the surface. That normal will be represented by R or N, and that N will be resolved into two components. One of them will be N cos theta and other will be N sin theta. That is the horizontal component and the vertical component. Now this fact we have to apply in case of a car taking a turn on the level road or the banking of roads. These facts are to be applied. So whenever car is taking a turn, we have to see the direction of centripetal force, the direction of normal reaction, the components, and the coefficient of friction. The friction between the tire and surface that will provide the necessary centripetal force to the car for taking a turn. So we come to the main context now. When a car takes a turn on a level road, the portion of the turn can be approximated by an arc of circle of radius r. This will be clear from the figure. If the car makes the turn at a constant speed, then there must be some centripetal force acting on the car. This force is generated by friction between the tire and the road, as I have just now explained. Car has tendency to slip radially, that is making tangent with the curved road outward. So frictional forces act always inwards. Now we can see the figure here. The car is taking a turn on the curved path. So what we are finding is that F is the force which is operating inward, R is the radius of the path, and in the free body diagram, the weight will work vertically down. The reaction to the weight will be N. Sometimes it is represented by capital R. So if the car is not moving, in that case, N will be mg, and F is indicating the force of friction. This friction will be between the tires and the surface of the road. Now, this force is generated by friction between the tire and the roads. Now, we are finding the car is moving, and when the car is moving, there will be friction between the tire and the road. And this coefficient of friction provides, or this friction provides the necessary centripetal force for taking a curve by the car. Now, mu s is supposed to be the coefficient of static friction, and is the normal reaction, which is mg. Mg is normal to the reaction of the surface. The maximum velocity v is mv square over r equated with mu n or mu r capital. So n can be replaced by r if it is reaction, but our assumption is that n is the normal reaction. So we have multiplied mu s with n. Now mu s written as it is, and n will be replaced by mg. Therefore, from this equation, mu s will be estimated by cancelling m, and will come to result that mu s will be equal to v square over rg, where mu s is the coefficient of static friction. And from this equation, we will make the subject of equation as v. V is calculated by function the coefficient of static friction multiplied by rg whole under the root, where r is the radius of the curved path and g is acceleration due to gravity. In most of the numerical problems where g is not being provided, we always take g as 10 meters per second square. Now, again in the figure, the same depiction is there. the normal reaction is against the weight. Weight is acting vertically down and normal reaction against the weight. And F is representing the force of friction. This force of friction is provided by the friction between the tires and the surface. So again, we are finding the car is moving in a curvilinear path, radius r, and centrally directed force is centripetal force. This centripetal force is provided by the friction between the tires and the surface. Now we come to the main context. Mu s is the coefficient of static friction, and is mg, normal reaction of the surface. The maximum safe velocity can be calculated as follows. mv square over r is equal to mu s multiplied by n. N is basically representing the normal reaction. Sometimes it is represented by r also, or we can write this equation as mu s mg. Now mu s can be calculated by cancelling m. It will be v square over rg, and v is equal to mu s multiplied by rg. Now this equation is independent of the mass of car. So whether the car has more mass or car has less mass, the safe velocity is the same for all vehicles of the larger and smaller masses. The formula to be used for finding the safe velocity will be v is equal to under root mu s rg. Now we come towards an example. A car is traveling at 30 kilometers an hour in a circle of radius 60 meters. Now we have to find what is the minimum value of coefficient of static friction for the car to make the turn without skidding. So the important feature about it, first of all, convert 30 kilometers per hour into meters per second. 30 kilometers per hour is multiplied by a number 5 over 18. It's a conversion factor, and 30 multiplied by 5 over 18, the result will be in meters per second. The radius is being known to us, 60 meters. So either perform the question in CGS system or in MKS system. So all units must be in sequence or they are consistent. Now in order to have the solution to the question, the minimum value of the coefficient of static friction, that is mu s, should be the formula as we have discussed earlier during the derivation, mu s mg, that is equal to mv square over r. Basically, mu s n we take and we equate it with mv square by r. But n is the normal reaction. So instead of n, we have computed mg. Mu s mg will be equal to mv square over r. And from this, we get the value of mu s, that is v square over rg. V is known to us. So by putting the value of v in the equation of coefficient of static friction, the calculated value will come to be 0.115, and mu s will have no units. So mu s is calculated by formula v square over rg. We can put the value of g as 10 meters per second square. R is the radius, that is 60 meters given. And then it is v square, and v square is found to be 25 by 3. But we will take the square of the number. So 25 over 3 into 25 over 3 multiply 1 over 60 into 10, and that gives the value 0.115. Mu s will have no units. For all values of coefficient of static friction, that is mu s, greater than or equal to above value, the car can make the turn without skidding. So if car has not to skid, then the velocity must be that must be taken as v, and the value must be taken as in terms of tan theta.